This is the Precalculus 2017 Fall ACP Sample Problems. The district provided a set of 20 problems to match the rigor and content generally of the assessment of course performance that's going to be given a week from now. And so I wanted to go over these problems and just show some solutions. One, a soccer player kicks a ball at an angle. The height of the ball in feet varies with time is given by the function h of t equals negative 16t squared plus 33t, where t is the time in seconds. What is the maximum height of the soccer ball to the nearest foot? Now on the word wall of my classroom is this thing right here. When, what? So what is usually going to be the y value, and when in time is going to be the x value. Also, another one that I don't have on the word wall is this one, time, height. Also, the word wall is not going to be available during next week's test. So anyway, that's something to consider. What I've done is I've previously entered a lot of these functions in the calculator, so I'm going to go to this one right here, and here's the one that's typed in. You have x instead of t. Press enter, and this is what we're looking like. We're trying to find the maximum height, and to do that, different ways to do it. If we go to menu and we go to trace, graph trace, we can just go, and when I press the next one, you're going to see a little flash. It says maximum at the top. You see that? Just went away. So it says 1.03 comma 17. So what this means is at 1.03 seconds, the maximum height of 17 feet was reached. And so we're looking for the maximum height of the soccer ball, and that being this one right here, 17. We just enter 17 and bubble in correctly. 1, 7, and we got to make sure we can put the 17 anywhere, but it has to be consecutive numbers with no decimal point separating or to the left, etc. And the scoring assumes positive by default, so we don't need to bubble in this plus here. So that's problem one. Problem two, the Texas Department of Public Safety collected data and stopping distance for a number of different types of cars. They found that one brand stopping distance could be modeled by the equation y equals 0.05x squared plus 0.1x plus 5.0. where y is the stopping distance in feet. Now, if you're not careful, I know one student did this one student plugged in 100 for x, okay, in both these places. And what did that student get for an answer? Answer choice D, 515 miles per hour. Now, is that a correct answer? No, it is not, and let me explain why. If you read carefully, as you should, y is the stopping distance, and also 100 feet is required to stop. So 100 doesn't go in for x, 100 goes in for y. Another thing is that in most test writers write problems and try to roughly be realistic. Now, is a car going to be really tested that's going 515 miles per hour? Now, that's going to be rocket-propelled car travel on the Bonneville Salt Flats in Utah. All right. C is likewise doesn't look like 176 miles per hour. That's going to be like a NASCAR or Indy type speed. So anyway, different ways to do this. You can plug in these values for x and see which one gets you closer to 100, and I'm going to show you how to do that. But I did graph this function, and if we go to Control I, we go to this right here, and if we add graph, and we graph this thing right here, we can go to the table view, and we can go here and see for x values, and I'm scrolling down the y values. We're going to see when we get to 100 miles an hour, which we get, it looks like between 42 and 43 miles per hour is an input value. We shift over to 100. So based on this estimation, A is going to be our correct answer. And then you can also plug in 42.6. I'm going to show you a different page way of doing that. Control I. So if we put in 42.6, we can go to Control var X, and then we can just type in the equation. We put 0.05 x squared plus 0.1x plus 5, I believe it is, and we get 99.998. So on this problem, A is definitely our correct answer. 3, a radioactive substance, cesium-137, has a half-life of about 30 years. It means that after every 30 years, half the amount of cesium-137 present turns into something else. If the initial amount of cesium-137 was 70 grams, what's exponential decay function represents the amount of cesium-137 remaining over time t in years? And so, one thing we have at our hand is what's called an ACP formula chart. And this exponential growth or decay, this function right here, we have key values here. This n sub 0 is called our initial value. This r is our rate, and it's not in percentage, it's going to be in decimal. And this t is going to be our input variable. Let me write that down, kind of ugly. Rate, and t, we'll say input variable. Input variable. And then n is our output. It's going to be our final value, our final amount. And I said, in this case, we're going to have grams, so we're going to have initial amount, final amount. Sometimes you see A sub 0 and A instead of N sub 0 and N, but it ends up being the same thing, same concept. So we go look at our problem again, and our initial amount was 70, and so we go look at our initial amount portion here, which I'm circling vertically here. So anything that's not 70 is a wrong answer. A is wrong, C is wrong. Okay, and then also in part B, you have the variable right here as an exponent. And so B is the correct answer. In answer D, T is not in the exponent's place. Okay, 4, a function is shown. Which statement best describes discontinuities in a graph of f of x? And you have different types of discontinuities. Well, if we just look at this, we should be able to see that this x minus 3 in the denominator cannot be equal to 0. So if we set x minus 3 not equal to 0, and we solve for x, solve this inequality for x, we have x cannot equal 3. And so A is definitely not a right answer. And so now it's determining which type of discontinuity it is. And there's a multitude of ways to do this that we've done in this class. One way is to take this x squared minus 9 over x minus 3 and seeing if we can simplify this and factor. Well, using the different squares, we can factor this x squared minus 9 to quantity x plus 3 times quantity x minus 3. And we're dividing, of course, still carrying over x minus 3. And what happens here is we have x minus 3 in the numerator canceling x minus 3 in the denominator. And so the cancellation makes this a removable discontinuity or point discontinuity. Also a couple other ways. We talked about using synthetic division. Right? If we take this 3 and our 0 is 3, and we have 1x squared minus 0 plus or minus 0x minus 9, and we just put our synthetic division down. If we have a remainder of 0, 3 times 1 is 3, 0 plus 3 is 3, 3 times 3 is 9, 0. Since our remainder is 0, that's also evidence of removable discontinuity. And finally, if we graph the function here, Control I, that graph, and we go up here, we'll put in this function that we had. Here it is. We graph this, we see no discontinuity at x equals 3. And if we go to table view, Control T, table view, and look at where x equals 3, we have undefined there. So a multitude of ways. 4 is the correct answer. 5, if x equals x minus 1 over 3, what is f negative 1 x? This f negative 1, this is called an inverse function notation. And we talked about steps in solving this type of finding an inverse function. Step 1 is we're going to change f of x to y. So here we're going to write this. We write this equation as y equals x minus 1 over 3. Step 2 is we switch places with the x and y. So we're going to write this as x equals y minus 1 over 3. Okay, step 3 is going to be solve for y, the new y in this case. So I'm going to rewrite this x equals y minus 1 over 3. And we're going to solve for y by first multiplying both sides of this equation by 3. So 3 of the 3 cancel on the right side, and then we end up with 3x equals y minus 1, and then we add 1 to both sides of this equation. And we have 3x plus 1 equals y. And then step 4 is we change y into f of x. So we can rewrite this as f negative 1 of x equals 3x plus 1. Obviously, our correct answer is B. We can also graph these functions and see which one. I did graph these in the calculator here too. Okay, we go to calculator, Control I. We'll go right up to where we were. There it is. So we graph this equation here, and we have the original function. And to find an inverse function, we're going to put in y equals x, f of x equals x. We get this green line, and then our correct answer choice, which was 3x plus 1, should reflect about the green line, be a reflection of that. So that orange or yellow line reflects as a reflection of that lavender line about the green line, which is y equals x. So again, this one, a lot of different ways of doing this problem. There's probably another one too. Yeah, you can find a composition of these two functions, and if the composition of these two functions simplifies to x, that's another sign. Okay, 6. A function is graphed on the coordinate grid as shown. And again, on my word wall, I have this thing right here. Okay, and let's see how it is. Okay, domain would be x values, range would be y values. And you see you have 3 sections of domain from greater than negative infinity all the way up to and not including 2. Okay? And the right piece is going to be at 5. It's going to be 5 up to not including infinity. And then in between you have this piece between 2 and 5. So we also have 2 comma 5 in the middle. Don't forget the middle piece, and they are connected usually by these U things, which means union. So A is going to be our correct answer. And range, similarly, is going to be from negative infinity to 0, and then again from 0 to infinity. The range will break at the x-axis. Should be pretty easy right there. Okay, 7. If the function f of x equals x cubed is changed to g of x equals quantity x plus 2 cubed plus 1, how's the graph of the function transform? Well, these functions here are going to be in the form, you have x minus h, in this case we'll say cubed, plus k. I know we see this usually for a quadratic function, but if h is positive, that means we're going to have x minus a number, and the thing will move to the right. But in this case, we're going to have x minus negative 2, right? So h would be negative 2, in this case cubed, and we'll have plus 1. And so we're going to shift to the left 2 units and up 1. And so that's going to be answer choice C. One thing you can do quite easily in the calculator is go like this. If we go to Control I, we can add graph and just put in x cubed, see what that looks like. Okay, and then to compare, we can go enter another function. We can put quantity x plus 2 cubed. Okay, and then over here put plus 1. Should shift to the left 2 and up 1. Certainly does. C is our correct answer. 8, what is the sum of the arithmetic series? And we're given this sigma notation here. And if we go to our ACP formula chart, this is what we get, sequences in series. And it's going to have to do with, we see the sigma notation here. And so we give different formulas. We're not going to use those right now. But what this tells us is we're going to sum a bunch of, in fact, 115. So our first term that we are going to calculate is we're going to put in 3 times 1 for k minus 2. And that's going to be 3 minus 2, which equals 1. Our second is going to be 3 times 2 for k minus 2, which is going to be 6 minus 2, which equals 4. And we could go on for the third term and so on up to 15. Well, that's a way to do it. We can find that final term, find the average using the formula in the formula chart. But one thing we have in our graphing calculator is we have this neat little feature here. If we go to this 9 key right next to it, we have this thing right here. So we can just go and put in k equals 1, and we're going up to 15, and then we're going to put in 3k minus 2. And we're just putting in the formula here, so we get 330. How hard is that? Not hard at all. So we'll just put this in. 330, that's 0, 1, 2, 3. Again, we don't need to put a plus because the algorithm assumes plus already. Okay, here we are on problem 8. If f of x equals 3x plus 2 and g of x equals 2x squared, what is g of f of negative 4? Sometimes you'll see this written as g of f of negative 4 like this. Okay, so you can write it different ways. Well, this -4 is closest to the f. So we're going to look for first f of -4. So we're going to plug in -4 for this x here. So f of -4 is 3 times -4 plus 2, which equals -12, plus 2, which equals -10. So now we're going to find g of -10, which equals 2 times -10 squared. -10 squared is 100. So we have 2 times 100, which is 200. So our correct answer, number 9, is C. Okay, I'm just going to leave that there. Okay, 10. A theater has 38 rows of seats. First row has 25 seats. Second row, 29 seats. Third row, 33 seats, and so on. So if we have 33 rows, we can just say, okay, first row is 25 seats. Second row is 29 seats. Third row is 33 seats. And we can see fourth row is going to be 37 seats. So our common difference for this is going to be D equals 4. We're going up by 4. And we just go on to this pattern until we have 38 numbers total. Add them up, we'll have our correct answer. But fortunately, there are a couple formulas that are going to help us out in this endeavor. And these are found also in our ACP formula chart. The nth term of an arithmetic sequence, this equation here, and also the sum of a finite arithmetic series. So we're going to need to find the thing for 38th row, the 38th term. So we want to find what's a sub n equals a sub 1 times, equals a sub 1 plus n minus 1 times d, and d is going to be our common difference, which we've already found is 4, right? So a sub 38, since we have 38 rows, is going to be equal to 25, and then we have 38 minus 1 times 4. So it's going to be, and I just didn't write it right, did I? It's going to be plus 38 minus 1 times 4. So we'll have 25 plus 4 times 37. And we can go to our calculator. 25 plus 4 times 37. We're going to get 173. So our answer we're going to find by getting this summation a sub k looking thing is going to be equal to n over 2 times a sub 1 plus a sub n, which equals, in this case, 38 over 2 times 25 plus 173. And 38 over 2 is going to be equal to 19. And then 25 plus 173 is going to be 198. And you don't have to simplify it as I did just now, but you can if you want to. So we get 19 times 198. We get 3,762. And that's our answer choice A. Next, 11. The function f(x) is graphed as shown. Based on this graph, f of x has, okay, real roots. A real root will be found where you're touching or crossing the x-axis. So I count 1 here, 2 here, 3 here, and 4 here. So the place where we see 3 real roots, definitely not the case. D is probably wrong here. It says 5 real roots. Now between B and C, you have 4 real roots and 3 local maxima. Well, there's only one local maxima here. But you have these minimums down here. Extrema means both maximums and minimums. It's kind of a Latin. So that makes C our correct answer. Next, 12. The steps Tamisha used to solve the equation 1800 equals 2400 times 21 minus r to the third power are shown. And so here's the first thing in this first step. We're going to choose which of these steps did she make a mistake in. So the first thing we're going to do from step 1 is we're going to divide both sides by 2400. So if we divide 1800 by 2400, we're going to simplify to 3/4. So step 1 looks like we were correct, or Tamisha rather was correct. And so step 1 is not the correct answer. Step 2 is to go from 3/4 equals 21 minus r cubed. What we're going to do is get rid of this cube by taking the cube root of both sides. Well, cube root of both sides, cube root is to the 1/3 power. So cube root and cube cancel each other on the right side, and then on the left we have to the 1/3 power. That is also correct. So step 2 is a correct step. Finally, we're going to solve, Tamisha solved for r, and so she adds r, to both sides of this equation, and she's going to subtract this 3/4 to the power of 1/3, and she is going to end up with step 3 correctly also. So step 3 is correct. So the correct answer is D. No mistake was made. Good job, Tamisha. Next, the graph of the function f of x equals square root of x is transformed following the given steps. Okay, so first thing we say is reflect across the x-axis. Well, the cube root function is, I'm just going to draw, it's going to look something like this. And if you're reflecting about the x-axis, it's not going to be answer choice A, nor is it going to be answer choice D, which reflect about the y-axis. Okay, so now we're between answer choices C and B, and what we're going to do is vertically stretch by a factor of 1.5. Well, both answers C and B look like they could be stretched by a factor of 1.5. Whatever case, they look similar. But then translate 1 unit up. Well, B is the one that translates 1 unit up and not C. So for this one, B is the correct answer. Should be a pretty easy problem. Okay, and then one thing I didn't talk about is knowing, says the square root function. We have to know our functions here, right? Square root, and that's going to be y equals square root of x. These are basic parent functions. We have the natural log function. That's another one of our standard functions, y equals ln x. We'll have the exponential function, which should be y equals e to the x, and e to the x and ln x are inverse of each other. It will have the absolute value function. Okay, it's going to be y equals absolute value of x. We'll have the reciprocal function. I'll just put recip y equals 1 over x. So knowing the basic parent functions of precalculus is very helpful, which helps us here for problem 14. Which coordinate grid represents the graph of the natural logarithmic function? Well, if we know the natural logarithm function y equals ln x, we can just go to our calculator and we can graph that function ln x. We go to control, e to the x, x, We graph the function. Okay, which one is this? Well, it should be pretty easy. It's answer choice D. Next, 15. What is the fourth term in the expansion of quantity 3x minus 2y to the 8th power? So it's a binomial expansion. We're looking for the fourth term. Well, the first term is going to be some coefficient, which we know for the first term will be 1 times 3x to the 8th power, and we're going to have times this next term, which is negative 2y, to the 0 power. And that's our first term. Our second term is going to be some coefficient times 3x to the 7th power times negative 2y to the first power. And that's our second term. Our third term is going to be some coefficient times 3x to the 7th power and negative, whoops, I got that wrong, 3x to the 6th power times negative 2y squared, and then we have plus some coefficient, which is going to be 3x to the 5th power and negative 2y to the 3rd power. And so we're going to have x to the 5th power and y to the 3rd power. So these answer choices like B and C that don't have x to the 5th power, y to the 3rd power are wrong. So we need to go find so we got NCR here, and it's going to be N is 8, C and R is going to be the fourth term. Well, 4 minus 1 is 3. And so if we just plug in NCR on our calculator, we go to Control I, and we go to our menu, probability, combinations. We're going to go to 8, 3, and we're going to get 56. So 56 is the number that goes here. And so we're going to get our answer for the fourth term is to be 56 times 3 to the 5th power and negative 2 to the 3rd power. We have x to the 5th, y cubed. So we can just put this in our calculator. So we have 56 times 3 to the 5th power times negative 2 to the 3rd power. So we get negative 108,864. But if we were thinking properly, we wouldn't even have had to gone this far, because we know if we cube this negative 2, we get negative 8, or a negative number. So we know that this would have to be a negative coefficient here anyway. So A is a correct answer for 15. 16, the Richter scale is used to calculate the intensity of an earthquake based on the amount of observed motion. And we can solve this different ways. It says 5.75 on the Richter scale. So if we say 5.75 equals 3.75 plus log, which is log base 10 of x. Well, we'll just say A, because A is what they use. So we have an equation we can use to solve. And one thing we have in our calculator, we have a feature called NSolve, numerical solve, which is menu 3.1 to get at it. And we have the equation, we just type it in, 5.75 equals 3.75 plus log, so we press log, oops, log is this one here. There we go. log base 10 of A. And we can just come outside of here and put comma A. And one thing we didn't have to do, we didn't have to put in 10 because the calculator by default assumes base 10 if you don't put anything in. So we get 100. And so that's pretty easy. And that's our answer choice D. Without a calculator, if we subtract on both 3.75 on both sides, we have 2 equals log base 10 of A. And that would be what to the power of 10 to the power of what equals A? Well, 10 to the power of 2 is equal to A, and so that would be also 100 equals A. That would be what you could do without a calculator. Now 17, what is the sum of infinite geometric series? And if you add these together, and if you spot a pattern, you could keep on adding, and there would be minus, plus, and get progressively closer to the correct answer and see which one is closest here. But we have a formula for summing a infinite geometric series, and it's right here. Sum of an infinite geometric series, and the formula is right here, this a sub 1 over 1 minus r. So we go here and put a sub 1 over 1 minus r. Well, we need to find out what a is. Well, a sub 1 is going to be negative 9/8. Okay, then we're going to say 1 minus r. And we need to find out what r is. Well, to get r, we take one term, r is equal to a sub n over a sub n minus 1. So we could take 1/3 over negative 1/2 and get what our r is. Well, for that, dividing by a fraction is the same as multiplying by reciprocal. So we can take 1/3 instead and multiply it by 2 over negative 1. And once we cross out and simplify and everything, we're going to get negative 2/3. So our r value is going to be negative 2/3. So I'm going to put minus negative 2/3. And now we have a formula we can use to find our exact sum of an infinite geometric series. So go to our calculator, put control, enter. Okay, I'm going to get another fraction on top, which is going to be negative 9 over 8. And then we're going to be divided by 1 minus, parentheses, negative 2/3. So we get negative 27 over 40. That's the exact answer. And if we found this negative 2/3 and kept on progressing and went out a few more terms, we would get closer. And there's a way to do it with the summation on the calculator too, but that will be your answer. If you just added these together, you'd be able to distinguish, you'd be able to cross off D, I'm pretty sure, probably A, and get between these two, B and C. That's another thing you can consider doing. 18, the population of small town is modeled by the equation P of n equals P sub 0 times 0.1 plus R to the n power. Again, we're getting back to our ACP formula chart, which is right here, and the exponential, oops, wrong way, exponential function, right? The population, and R, rate, this is going to be not percentage, but decimal. So we go back and look at this, saying if the annual rate was 7.5%, right? So 7.5% is going to be dividing by 100. It's going to be a decimal of 0.075. So you got to be looking for that. And so you're not going to be answer choice D, nor are you going to be answer choice B. And then you're going to say population doubles. Well, that means you're going to start from, like in this case, 45,000, and doubling would be 90,000. So our correct equation would be this one right here, C. 19, if the domain of f of x equals 2x squared minus 1 is restricted to 0 to infinity, which graph represents f negative 1 of x? One thing they're doing here is with the answer choice, they're kind of tricking you. You see this domain restriction, and you say, well, obviously that could be like C, or maybe A, because the domain doesn't start here. But what you got to do is look at the original equation. So you got 2x squared minus 1. I think I previously put in the graph. So if we go to 2x squared, no, I don't think I did here. Anyway, so we'll put 2x squared minus 1, and we get this parabola here. And we're interested only in the right half here, because the domain restriction from 0 to infinity is only going to take this right part. So going back to our problem, what we're going to do is take this function. I'm just going to draw it in here. Okay, we saw the other half of the graph be like this, right? What it's going to do, it's going to take the inverse of that. It's going to look something like this. Okay, it's going to be about the line y equals x. And so you're looking at the best fit for that. Now B is kind of a contender, the way it looks. But if you look carefully, D is the correct answer. So that's one of the things that you really have to distinguish here. But that's our answer, D. And also you could take, if you just said, okay, we're going to take the inverse, we're going to take y, the four-step process, right? The first step, we could say y equals 2x squared minus 1, and then we switch x and y, right? So we have at 2y squared equals x plus 1, then we divide by 2, we get y squared equals x plus 1 over 2, and then we take the square root of both sides. Well, we're going to have plus or minus square roots. We're going to have y equals plus square root of x plus 1 over 2. And you're going to get the answer choice we talked about, D. And then f negative 1 of x, right? Okay. The last one in this set we're going to look at is which equation represents horizontal asymptote for the graph of the function f of x equals negative 6x cubed minus 11x squared plus 8 over 2x cubed plus 5x minus 4, and plus 5 outside of that. And I previously graphed this function here at graph, and here we go. I'll find it here. There it is. And we graph this function. That's what it looks like here in orange. And we could look at this a number of ways. One way to do it is just as we did earlier, we just trace and graph trace, and we can just go to the right and see what number we're approaching on the y value. See, we're now for 4.5, x equals 4.5, we have 1.21. As we go to the right, okay, I'm just pressing the button, and we're going up now through x equals 20. We're at y equals now just about 1.9. Okay, y equals x equals, now we're going up to 90, 100, and we're up to y equals 1.96, and so we're approaching 2. So 2 is going to be our, y equals 2 is our correct answer. One thing, there's an analysis way of doing it. If you take the highest coefficient here, which is going to be y equals, we can take negative 6x cubed over 2x cubed, and then we have this plus 5 outside. We just take the highest ones for the limit, and we have x cubed or x cubed cancel each other, so we have negative 6 over 2 equals negative 3 plus 5, which equals 2. So anyway, those are the problems worked out. Good luck, and thanks for viewing.